and I'm currently in the 11th grade, and I attend St. Francis High School.
I'm Camille. I go to the Nueva school.
I'm Aneya. I go to California High School.
And I'm Crystal, and I go to American High.
Yeah, and today we'll be doing a predictive study on the sales of cardio good fitness treadmills, and we belong to the Professor Dharmale crew. So, currently, regular to moderate and vigorous physical activity is widely promoted as a cardioprotective measure to prevent cardiovascular disease. Physical inactivity and sedentary behavior has always been a worldwide concern, though, especially during the COVID-19 pandemic. The amount of time sitting has been reported to increase by 28%. In order to continue exercising, many people bought fitness equipment at home after gyms and fitness studios closed due to social distancing. Among the different types of fitness equipment, treadmills were the most popular ones bought. This led to an increase in treadmill sales from 11 million to over 15 million within 2 years. In order to help the treadmill companies better market their treadmills towards users, this study aims to use machine learning to analyze customer behavior and predict the preferences of customers regarding treadmill products.
The goal of the study is to use machine learning to analyze consumer behavior based on factors such as demographics, past purchasing behaviors, and the consumer feedback to identify the influences on the consumer preferences. By doing this, we hope to develop a predictive model that can accurately predict consumer preferences when purchasing treadmills. These findings will be used to help fitness equipment companies optimize their product offerings, marketing strategies, and consumer engagement initiatives in order to help increase their treadmill sales.
Okay, in terms of methodology, we have 5 main steps. The first one was data collection. So all our data was gathered from the Cardio Good Fitness database, which has customer information like demographics and product feedback. And we also used external sources like online reviews. The second step was data processing. So we did data cleaning, normalization, and feature engineering to prepare the data for the model. Third is the exploratory data analysis to gain insights on different patterns and correlations between variables. In terms of the model, we use different machine learning techniques like classification, regression, and clustering to implement the predictive model. And then finally, for evaluation and validation, we use different techniques and metrics to evaluate the accuracy of the model.
So data collection, all the data from the study is from the Cardio Good Fitness customers, which is a retail store that sells fitness equipment like treadmills. And this study specifically looks at 180 customers. The data fields studied in this data set are product, age, gender, education, marital status, usage, fitness, income, and miles. Product is the model number of the treadmill. Age is how old the customer is in years. Gender is whether the consumer is female or male. Education is how many years of education the consumer has. And marital status is whether the consumer is single or partnered. Usage is the number of times the consumer aims to use the treadmill every week. And fitness is the self-rated fitness score of the consumer, with 1 being very unfit and 5 being very fit. Income is the annual income of the customer, and miles is the number of miles the consumer aims to run every month.
So
Okay.
actually, no, go ahead.
Okay, this is a little bit of a data overview. We have a bunch of different variables like age and education, and then on the side we have different statistics. The maximum income of the customers is 100K. The average income is approximately 54,000, while the median income is approximately 51,000. And all customers using treadmills are between the ages 18 and 50. And the average age of the customers is 28.78, and the median age is 26 years old. Every customer expects to use the treadmill at least once a week, The maximum usage is 7 times a week, and the average or the maximum usage is 7 times a week, and the average usage is 3 times per week. On average, customers aim to run 103.19 miles per month, and the median amount of miles run per month is 94 miles. The average self-rated fitness score of the customers is 3. All customers have between 12 and 21 years of education, with the average and median amount of education being 16 years. And finally, the max amount of education is 21 years.
So when we look,
Yeah.
when we look at each
I have
model, okay, so when we look at each individual model,
Wait, somebody has question? Yes.
sounds like huge. 16 years elementary school and kindergarten, or that's just college?
You want to put your question in the chat, Marks, because you broke up, unfortunately.
Oh, sorry. Okay, I said that sounded huge. 16 years, does that include kindergarten, elementary, and middle school, or that's just college?
that's I think it's probably just I think that is just a that also includes middle school, kindergarten, elementary. It's just how many years of schooling they had in total. So it's not just college.
Okay, now it makes sense.
Okay, so if we look at the individual data based on each Treadmill model, from what we noticed, 80 customers bought the TM195 Treadmill model. Their average income is approximately 46K, while their average age is 28.5 years. Each customer aims to use the treadmill at least 3 times per week and run at 85 miles per month on average. On average, the self-rated fitness score of the customers is 3, and they also have 15 years of education. For the TM498 model, 60 customers bought it, with their average income being 48K per year and their average age being 28.9 years of age. The customers aim to use the treadmill at least 3 times per week on average and run 60 miles per month. Their average self-rated fitness score is 3, while their average years of education is 15. And then for the TM798 model, 40 customers bought it, with their average income being 75K per year and their average age being 29 years. They aim to use the treadmill on average 4 to 5 times per week, and they aim to run 166 miles. The average self-rated fitness score of these customers is 5, while their average education is 17 years. And then we didn't include gender and marital status in this analysis because all of the ones because they're string values and you can't really find the mean of string values, whereas all of the values we calculated for the mean on the graph, they're all numerical values, so we can find the mean of them. So that's why gender and marital status are not included on this table. And then within the data, there's some missing or blank information. In order to fill in the missing data, we first calculated the mean or median of each numerical demographic and then filled in the missing data using either of those accordingly. For example, for age, education, and usage, we filled in the missing values using the median. For income and miles, we filled in missing values using the mean. And for missing marital status, we just automatically filled in partnered because a marital status is a string value, so we can't really find the median or mean of that, so we just automatically filled in partnered.
And then later what we did in our exploratory data analysis is we did a univariate analysis and a bivariate data analysis. And so what a univariate analysis is when we analyze one feature of our data, we determine if that data is skewed to the left, right, or if it's center. And this helps us determine like what sort of observations we have of the data, whether, like for instance, age, whether we have younger customers or older customers, or if we have higher income earning customers or lower income earning customers, and the types of graphs that we use for a univariate analysis are histograms and density plots. And then another type of analysis we did was bivariate analysis, where we analyzed two features of our data. We can determine if there is a correlation between those two features and see how those values compare to each other. The types of graphs usually used for bivariate analysis are bar plots and box plots. Box plots, which we will see later in the upcoming slides. So if we look on this slide, we see that we've done a univariate analysis here. We've done a univariate analysis of our numerical features, such as age, education, usage, fitness, income, and miles. And from our univariate analysis, we can conclude that age, education, income, and usage were skewed to the right. So that indicates that we had younger customers and lower income. We had younger and lower income customers buying the treadmills. And then here we did a bivariate analysis of our data. In our box plot that you see, we plotted the income, and each box plot is according to the product of our data. And so in this box plot, we see that there were more wealthier customers who bought the TM798. And then in the other plots we'll see later, we see that there are more men than women who bought the TM798 versus the TM195. We still have to analyze why. And then in another plot we'll see that there are more partner customers who are buying each product. So in this plot we see that there are more partner customers buying each product in comparison to single customers. This could be attributed to the fact that a partnered couple would have a greater combined income than a single person. So that could explain why there are more partnered couples buying treadmills rather than single couples. But we still have to ensure this through more data analysis. And then here is a plot of our income versus product, and each point is colored according to gender, orange being female and blue being male. And so what we see here is that, especially in the TM798, we have more male and partnered customers buying the TM798. And this makes sense because partners would share a treadmill, so that might explain why there are more male customers in our data set rather than female customers. However, in the other data set, we see that there are an equal number of male and female users, and that could be attributed to the fact that there might be more single customers buying it, so that could explain why there's more representation in female customers buying the TM195 and TM498. And then here's another plot of income versus gender. And so we see here is that our data set contains men of more different backgrounds in terms of age and income. There are more older men and there are more wealthier men buying our products, as well as men who are not as wealthy and who are younger. However, when we compare that to the data collected about women, we find that the female customers who bought treadmills were around the same age and that they were earning around the same amount. And this is important because it could lead to a bias in developing our model, since there are more men of different backgrounds than women.
So from what we noticed, we found that most of the customers aim to use a treadmill at least 3 to 4 times per week. However, we noticed that 43% of female customers will expect to use the treadmill 3 times per week, and 26% will be twice a week, and 72% of male customers will use the treadmill 3 to 4 times per week. So usually most of the customers are going to aim to use the treadmill around 3 times on average. However, if you look at the amount of females who say they'll use the treadmill more than 3 times per week compared to males, we found that there's a significantly higher number of males who say that they'll use the treadmill more, and this could be because females may also have to do a lot of other stuff outside of their jobs, like take care of their families, so they may not have as much time to work out. So that's why they may report the amount of time they'll use the treadmill as lower. However, we do not have any data for this. Another thing we notice is that usage of the treadmill increases with age up until 28 years old, and after that it goes down. At 28 years old, the usage is highest at 6 times per week, and the age groups that uses the treadmills the least is from 30 to 40 years old, with from the mid-30s to mid-40s having little to no people using the treadmill. This could be because as the customers are young, they may want to improve their fitness and work out more, and they may feel more, as a result, they may be more inclined to use a treadmill. However, after like age 28 and like in their like mid-30s to 40s, they may be less inclined to use a treadmill because they feel like they're healthy, so they may not have the need to work out, and they also may have a lot more responsibilities for their jobs. So as a result, this could cause them to also not have as much time to use a treadmill. However, we noticed that people start using the treadmill again from like ages 45 to 50, and this could likely be because as the customers are getting older, they may care more about preserving their health. And then as we notice, this is mileage versus age, and it is very similar to the graph of usage versus age as discussed the last slide. So we notice that the amount of miles ran per month increases until age 30, and then after that it decreases. And then similar to the last graph, there's also a huge gap between the mid-30s to mid-40s. However, it increases again at age 45 to age 50. The reasons for this are probably very similar to what we discussed in the usage versus age, where customers in their mid-30s to 40s may not have as much time to work out because of their jobs. And then we also look at fitness versus gender. According to this histogram, we notice that on average, most customers rate their fitness as 3. This applies to most males and females. However, we notice that male customers tend to self-report their fitness score as higher because there tends to be more 4s and 5s on the distribution, whereas for females, there are more 2s. This could likely be because similar to gender versus usage, females may not have as much time to go to the gym because apart from their jobs, they also have to do things like take care of their families. So as a result, they may report their fitness score as lower. And then as we see, usage of fitness also has a positive correlation. This is because the more someone uses a treadmill, the higher their cardiovascular fitness is going to be. And if you look at these small circles are actually outliers. So that means they aren't really calculated in mean and median calculations because they're so far off from the data.
And so here what we did was we created a pair plot of our data. The blue points represent males and the orange points represent females. And so what a pair plot does is then essentially it creates like this giant matrix of scatter plots and just see like how each variable kind of correlates to each other. Like for instance, if we look at the education and age plot in the top left corner right next to the density plot, we see that education and age have a positive correlation. And similarly, we can see like how each of the variables listed at the bottom kind of correlates to one of our rows here. And this is extremely useful in our data analysis as to seeing how strongly correlated each of the variables are. And on the next slide is a continued pair plot. Since we weren't able to fit everything into one slide, we split it into 2. And so if we see here, we just see how each of these features has a correlation with each of its rows, columns.
Then if we look at this heat map over here, a heat map measures the correlations between 2 quantities. And each box represents the correlation between the corresponding y-axis represents the corresponding represents the the correlation value between the corresponding x-axis characteristic and the y-axis characteristic. So as we notice, Asian income is very highly correlated, and this is likely because the more a customer works, the more likely they're going to be able to get promotions and salary raises, hence the higher income. And then we also notice that education and income also has a higher correlation because someone with a higher education is more likely to have a higher paying job. And also we notice that the three characteristics of treadmill, mileage, and fitness are also really highly correlated. And this is because when someone uses a treadmill, they'll run more miles, and hence they'll have a higher cardiovascular fitness.
So in the future, going forward, we hope to advance the deep learning model to forecast what customers are going to buy. The methods and techniques we intend to use are as follows: improving feature selection to ascertain what features can aid us in developing a more accurate machine learning model, formalizing the data in our data set to develop a more streamlined algorithm, and using the SMOTE technique, oversampling minority and undersampling the majority, and finally, splitting the data into training, cross-validation, and test set.
Yeah, are there any questions?